Hello everyone, welcome back to my YouTube channel. My name is Turgut. Today we will use a language model for text generation, and we will learn how to set their hyperparameter for this purpose. We are going to use GPT-Neo 1.3b from the EleutherAI. We will explore how this powerful language model generates text and how can we set its hyperparameters. First thing first, let's talk about the architecture. GPT-Neo 1.3b means it has 1.3 billion parameter. It's relatively, when you compare the huge model, it's a pretty small model. And this model is their first, based on their first GPT-3 model architecture. And this is built on the transformer architecture and feature attention mechanism for parallel processing. And this model is trained on the PILE data set. And this is the, I'm going to leave its link here. You guys can check the paper and also see how they trained. Okay, so the objective of this model, predict the next word in the sentence based on the context of the previous words. Our model had produced the logics for each token in the vocabulary, and using this. Then after that, using the softmax function, we are getting the probability distribution for the next token, and then picking the highest probability words, and it's like the model's best guess for what's come next. Okay, so when it comes to generating text, we have options. Using options for using these models. It's greedy search, beam search, top case sampling, top case sampling, and temperature. Each has different effects on our model text generation quality. Let's explore how they influence the outcome of our language model. Okay, all right, let's see the action. Okay, so we have here, and I created this notebook early on, and I run this to cell, and we are going to use this imagine you are on as our beginning prompt, and then send it to our model, and let's see how it's generate text based on this. Okay, here, and I'm importing the necessities here, PyTorch, import torch, and from transformers, we are going to get our transformers from the Hugging Face hub and auto tokenizer to get its tokenizer, and also auto model for casual language model. Okay, so we are just getting our pre-trained model and just attaching to our device, which is CUDA in this case. It's just basically GPU. I'm using ChatGPT. Sorry, not ChatGPT. Sorry, Kaggle notebook, and you can use these accelerators here in certain amount of time. It's free, and you guys can use it in time. So let me run this code and explain later. So we have our starting prompt. What's going to happen? Okay, this is our outcome. What's going to happen here? And we have choice 1, choice 2, choice 3, choice 4, choice 5. We are just seeing the most possible choices, which choices are highly likely, and choice 1 is the first one. That's why our model just picking the choice 1, and just you can see their probability is higher than the others. Imagine you are in a plane and you are reading a book.u. Okay, then it will create as a 10 next token. Okay, so number we set, because we set the number of generation steps to 10, we basically we are generating this text iteratively. We are saying with torch no grad means we are not calculating gradients because we don't need it, because we are not, there's no back propagation, there is no optimization here. We are just using our model for text generation purposes. Okay, we are just generate token probabilities using for our model. We are sending token input tokens to our model. It's produced as an output. We are just using those probabilities, sending the softmax and getting our probability distribution. We are sorting those probabilities and getting the high probability one, which is the first one, A in this case. And then we are just showing the other choices here. Okay, so you guys can compare this here, and that would actually better visual, but that's okay for now. Okay, this is the same thing, just show the, one output, and we don't even have to run it, but to show you, imagine you're on a plane and you're reading. Yep. Okay, so we have here, and I'm going to explain greedy search here. We have this sentence here: the ancient oracle foretold a hero rising from ashes, but only the whispers of forgetting magic offer clues. Where does hero journey begin? I get this prompt from a language model again, and let's see how it's worked. Okay, greedy search basically is just, so we are using this greedy search is will find us a local optima. When it start to predicting the new word, greedy search always get the highest probability for that word the next from our dictionary. So, as you can see, when I run this cell, yeah, as you can see, after the, this is our beginning sentence, the hero journey, a journey of self-discovery, a journey of self-discovery that begins in self-discovery. It starts to repeat itself because this algorithm keeps picking the highest probability words. There is no diversity. It's just start to repeat itself. And you guys can check this algorithm here. I'm going to leave it's just basically finding the local optimal choice each stage. And of course, there are use cases. That's why I share this algorithm. If you are using the just small labels or small calculation like this, and just if you are just first choices, it will be enough for you, not just generating human-like tests. Is not the point for the greedy search algorithm. But as I said, for small choices or just labeling or getting the small answer, that will be a good choice for you. Okay, let's get the beam search algorithm. Basically, beam search algorithm, what it does, it has a width parameter when we are using beam search algorithm, and we can set this band width of this beam search algorithm. Let's say, and I gave an example here, let's say 3 in this case. This algorithm is going to looking at our logits, our probability distribution, and we'll pick the most possible 3 word from our dictionary. And when it start to and then let's say we just picked as a first word, but it will increase our computation because now we are just using 3, and we have, let's say, 1,000 words in our dictionary. It will be 3,000, and it will increase our computation. But it will give us a more diverse and much more human-like text when we are using it. Okay, let's say in the beam search, we just first sentence are let's say first words beam search algorithm picked is the hero and journey. Given the first word, what is the next word? Now it will going to use this first word and just add those tokens from our dictionary, find the highest 3 possible outcome. So let's say it will be the hero starts, let's say hero begins, and I changed the example here, just forget about this. And now it's just get rid of the journey, and now we have the hero start, and hero begin. These are the 3 possible outcomes. Then it will use those 3 and go on, so on, until the end of the sentence tokens. Okay, so let's run this one and see. We were just setting the beam search number of beams is the 3, and we will see there is no repetition here. After our sentence, the Oracle of Delphi was a great priestess who lived in the 3rd century BCE. She was renowned for predicting the future. As you can see, this text is much more sense, and our model is giving us some better results. But by the way, let me remind you here, for the use greedy search algorithm, you need to do sample method false, set the do sample method fast, because we are not sampling anymore for greedy search, because we just need highest probability word. Okay, the word which has highest probability. Okay, let's just set the number of beams to 5, and let's see how it will change. Okay, so this is the first in the 3-part series exploring origins of the hero's journey. Okay, increasing number of beams, of course, it has a cost, but it will increase our diversity because we have more choices. But I must warn you, if you increase really make bigger number of beams here, it will eventually just find the same sequences and it will start to repeat itself too. So you need to find a balance here. Also, you have to take account of your computation power for this model. Okay, so let's jump on the temperature here. Temperature is basically a hyperparameter. It regulates the randomness, creativity of our language models. And we were basically setting this temperature. We are controlling our probability distribution. So how it works, if we are, increase, let's say, if we are making higher than and closer to our temperature, it will start to give, and we will just increase our randomness and increase the creativity of our language model. And every word in our dictionary will become equally likely. So instead of the highest probability word, we will see the, even lowest probability words too, because we are just, giving all of them, same chance. So let's just run that and you will see what I mean. Okay, this is our, prompt, and let's see. Okay, as you can see, it is almost nonsense. It is not even relevant with our prompt here. Okay, so just increasing temperature is, of course, increase our creativity and randomness of our model, but we have to be careful, find a balance, otherwise we will get these weird results. Okay, let's just pick an temperature here. We made 2.0 here, but let's say temperature 0.6. I just, set top K to 0. This is a different thing. I will just talk about a little bit later. Okay, just let's run this cell here. As you can see here, the Oracle Delphi was a goddess with a mysterious past. She was the goddess of wisdom with ancient history that spans from the time Pharaoh, etc. Okay, so when we decrease, now our models start to pick the highly likely words, just giving more chance to highest probable words in our dictionary. Now we are getting much more better result from our model. Okay. I hope you guys understand this part. Let me know if you have any question at the end. Or just leave a comment, I will explain. Okay, we have another thing is top K and top P. So these techniques are regulates our token selection. Top K is basically is arranging, we are just saying pick the best options. If we give top K is 40, it will just limited our word and it will decrease our diversity, but it will give us a highest probable word. Let's say first highest 40 probable tokens from our dictionary. But it's just we will get the best words, but avoiding gibberish, but it will just it will give us a safer result. But what is top P is, we were just basically, with top K, we were just increasing and enhancing our fluency of our generated text, but we were decreasing the diversity. But with top P, this language model and sets the cumulative, it's going to set the cumulative probability threshold. So what does that mean? Let me show you with an example. And when we are just saying then, if we are increasing the cumulative probability, we will getting the it will decrease the, of course, the diversity. When we are decreasing the top P value, it will lower our cumulative probability threshold, and it will give us a much more diverse sense because it will start to include the lower the words has lower probabilities. Okay, let's see here. We are just saying top K is for the, okay, let's read it. When the walls came down in the late 70s, one neighborhood in Los Angeles was more devastated than the rest of the city, and such was known the Cave of Angels. This was group of the homes in Mission. Okay, it's a really fluent word, and it's just starting the top 40 tokens from our dictionary, and it's just fluency is good, but we lowered our diversity from our generated text. Okay, let's see the top K. We are setting top P to 0.9. We are just we basically increase the value, and we are saying give me the above this cumulative probability, which words are above. Okay, let's see the Oracle. What is the Oracle secret? Oracle is legendary warrior of Greek legend. His name is Oracles, believed to be a combination of Heracles. It's yeah, as you can see, is more diverse and nice, fluent result. But as you can see, the top K is much more fluent. Let's decrease the top P here. Yes, as you can see, sitting on the bottom of the stairs, and young man Zuri can help but smile at the step of the patrol. Zuri eyes narrow, walks down. Yes, but now, yes, we are make it more creative, and because we, decrease the cumulative probability for top P, but as you can see, it will now just a little bit lost the context. There is no hero, no journey, no oracle, nothing. It's just somehow lost the context too. Okay, this is it, guys, and this is how can we just. Of course, there's a max length too. And I hope you guys enjoy it. Let me know if you have any question, and leave in the comments below. And there will be another series of the videos about the large language model, and there will be even products I'm planning to share in the YouTube with the notebooks. And thank you so much for watching. I hope you guys enjoy.